Welcome back, everyone. We're going to be solving LeetCode 1791, find center of a star graph. So there is an undirected star graph consisting of n nodes labeled from 1 to n. A star graph is a graph where there is one center node and exactly n minus 1 edges that connect the center node with every other node. And we are given a 2D integer array called edges, where each edges of I is going to be equal to u of I, v of I, indicates that there is an edge between the nodes u of I and v of I. We need to return the center of the given star graph. So we'll take a look at example 1. We can clearly see that 2 is the center, right? All the other nodes in our graph point to 2. So that's what we have to find out. If you're not familiar with graphs, generally we build either adjacency matrices or adjacency lists, and most of the time you're going to be using an adjacency list, so that's what I'm going to be using to solve this. It's just a dictionary with every node in here as a key and then all of their edges, right? So 4 would be a key and then 2 would be a value of 4. So I'm gonna show you how to build that first, and that's generally all we need to solve this problem, and it's what you would have to use to solve a majority of graph problems. So what we want to do is we want to loop through our edges, right? So we'll say for if I can type today, for edge in edges, right? We know that each edge is just 2 different nodes, right, u and v. So we can say, let's say node A and node B is going to be equal to our edge. And what are we going to do? We are going to say, okay, well, if A is not in our graph, right, we need to add it. And if B is not in our graph, we also need to add it. So how are we going to do that? We will say if A is not in our graph, we will add it. So graph of A will be equal to something. What are we going to set it equal to? Well, we want to set it equal to an empty list for right now, because we want this list to contain all of the edges of A. So if A was 2 in this case, right, it would contain 1, 3, and 4 as edges. And we want to do the same thing for B. So if B is not in graph, what are we going to do? We are going to add it. Graph of B is going to be equal to an empty list. Okay, so once that's done, if these don't execute, right, that means A or B is in our graph. So what can we do? Then we can just simply add the edge. So we'll say graph of A dot append B. So whenever we run into A, we know that we have to add the edge B to this list. And then we will do the same thing for the B node. Append A. So let's print this out so everyone can see what we have so far. So we'll run this. So now we can see we have this dictionary with keys and values where node 1 has an edge pointing to 2. Okay. Node 2 has an edge pointing to 1, 3, and 4. See, 1, 3, and 4. Node 3 has an edge pointing to 2. Perfect. And then node 4 has an edge pointing to 2 as well. So now what we have to do is simply, we know that the center node contains exactly n minus 1 edges, and they give us the edges here. So if we can find out what node has however many edges they gave us at the start, then we know we have found our center graph. So what we can do is we can just say for edge in our graph, if the length of our edge is equal to the length of our edges, then we can return true. Otherwise, we can just do a latent return false. And this should give us our answer, so let's give it some space and run this. Int has no length. Let's see here. If this should be the length of graph of our edge. Okay, now that should work. Alright, what is going on? Output is true, expected 2. Oh, we want to return. I guess it would help if I read the problem statement a little more, huh? Okay, so we want to return not true or false. We want to return the edge. And let's just make sure I'm not missing any other constraints here. Okay, so we don't have to return false. So we're guaranteed. Okay, so this should be it. Yep, and it is. So again, we are building a, well, let's submit this before I go into any more detail. Make sure it runs. Okay, perfect. So what we're doing is we're given a list of edges, right? And then what we want to do is build our adjacency list or adjacency matrix, whatever one you want to do. I generally prefer adjacency lists, which is what this is. We want to grab every edge in our edge list and destructure it and add those nodes and edges to our graph. And then for this problem, they obviously want the center node. So at the end, you can just loop through your graph, and if the length of the key of our graph is equal to the length of however many edges they gave us, then we know we have found our center node, and so we can just return the edge. All right, that'll do it. Oh wait, time complexity, sorry. Time complexity is going to be, it's going to be O of n to build our graph. So O of n, and oh, and then this one too. We have to loop through our edge graph, so that's going to be O of n as well. So our space complexity is going to be bound to the length of our graph. So we can say graph dot length. Alright, sorry about that, guys. Got a little ahead of myself and pretty slow on typing today, but that'll do it for LeetCode 1791.